I'm Christina Tonvold, the founder of Build Math Minds and one of the admins of the group. So every month we watch out for a hot topic, something that sparked a lively debate, a lot of comments, some unsureness, or anything like that we think, oh, this might be interesting to dive a little bit deeper into. Our hot topic this month, I wrote this week, but it's this month. Our hot topic this month inside of the Build Math Minds Facebook group is about why multiplication is not just groups of. We had a post, and Saring, let me know if I pronounced that correctly. Saring had posted this question: how to phrase this multiplication problem? 4 times 6, and she just has the digit, the symbols, 4 times 6. 4 added 6 times, or 6 added 4 times. She said, as phrasing it, this problem into word changes the meaning of the visual. And she's very right, okay? There are a couple of points that I want to make around this. So the first point is that in the comments, a lot of people were saying it's groups of, and specifically saying it is 4 groups of 6 because it says 4 times 6. Well, saying groups of is not the way that everybody says it. In the United States, yes, it is most common to say groups of, and we will say the first number, we will say 4 groups of 6. However, Saring did say in her native country, which I believe was Tibet, she said they actually say the first number, or the second number first. So they do say it as groups of, but they say 6 groups of 4, right? And we know that through commutative property, it really doesn't matter, but that's another point we're gonna get to here, okay? But the idea is that, yes, in the United States, we tend to say groups of, and we tend to say the first number and then groups of the second number. However, that is not the way the world does it, right? A lot of people don't even say groups of. They will say, what's the one that I have heard a lot of times? That instead of 4 groups of 6, they will say 4 taken 6 times. That's the way that I've heard it a lot in other ways. And just really the point here is to think about your group of students. Even if they all, are kids who have grown up in the United States and have been exposed to what we would think, are typical ways that we talk about things, you've got kids who may not have ever heard it in a specific way, and only, like growing up, I only heard it as 4 times 6, not even the groups of in there. So we want to expose kids to lots of ways to think about it, okay? Lots of ways to think about it. And in fact, groups of is just a starting point. It is a great starting point for our early learners because it does give us great visuals to group things around. But really, that's not the only way to view multiplication. And in fact, this is one of my favorite books. Sorry, my audio may be cutting out because I just blocked my face. This book is published by National Council of Teachers of Mathematics, NCTM, Putting Essential Understanding of Multiplication and Division into Practice. If you work with 3rd through 5th grade, one of the big things you are focusing on is multiplication. That book should be in your library. It is one of my favorites. So in that book, on page 11, they actually start out with a chapter all about the meaning of multiplication. So they say, and I'm going to look at this so I quote it correctly, they say that multiplication is a scalar process involving 2 quantities, with one quantity, the multiplier, serving as the scaling factor and specifying how the operation resizes or rescales the other quantity, the multiplicative unit. The rescaled result is the product of the multiplication. So even with this scalar process definition, viewing multiplication as scaling, you can make the case that when you see 3 times 5, you think of it as 3 groups of 5 because you are taking the 5, that group of 5, and scaling it up 3 times, right? That is what you're doing when you say it groups of. But keep in mind, that's not the only way to view it. And the second point I want to make about this is that we need to understand that progression of multiplication and keep that progression in mind. That just because the way we teach it right now with whole numbers and single digit whole numbers, is that going to work all the way through to build their understanding of multiplication throughout with all kinds of numbers that they're going to work with? So one of the hard parts with multiplication, if you view it as groups of, and which we should, that is a version of it. But often, especially in the early grades, when we view it as groups of, that can often be translated to kids, whether intentionally or unintentionally, that it is just repeated addition. You can solve that by using repeated addition, but if repeated addition is the only view that students have of multiplication, it becomes very difficult to help them understand multiplication when they get into problems that are involving fractions and percentages, right? So let's think about how we explain or talk about 2/3 times 3/5, right? You can't do repeated addition to solve 2/3 times 3/5. But you can think of it as that scaling idea. So I'm going to bring up a little visual here to help us out. So this is, I'm using Braining Camp, but if you have some manipulatives, anything that you want to be able to use. So let's think about that 3/5, right? Here's 3/5. If we think about it as scaling, one of the things that we can think about is like if you were doing, I just want to make sure. Okay. If I scaled it one whole time, it would be this entire thing, right? That's when I multiply it by 1, when I scale it one whole amount. But the problem was, let me see, right? We did 2/3, sorry, this is always wonderful. 2/3 times 3/5. And I know I probably should have switched from the highlighter to the pen, but I was trying to do it quickly. Okay, so what that means is I don't want to scale it one whole time. I only want to scale it 2/3 of the amount. I only want to build it out 2/3 of the amount, right? So if I take this, I think about it like this, right? This would be, does this make sense? Right? This is 1/3 of that amount. This is another 1/3, and this is another 1/3, because 3/3 would make that whole amount. So this is just showing it scaled, whoops, 2/3. That didn't come out very good. 2/3 of that 3/5. Right? I'm doing 2/3 of a group of 3/5, right? So as they progress up into multiplying with fractions, it is helpful to think about it as this scaling. So let me, let's think about it as, what if I wanted to do, let me just go, I'm going to go to just 2. Where's my eraser? Let me get the eraser. I'm not very proficient, not very fluent at this very much. So let's come back and then let's try thinking about it as, what if I did 2 times 3/5, right? I'm going to take that 3/5 and scale it up twice. So I'm going to take this amount, this whole amount there, and scale it out twice. Let's see if I can get another one of those. Right? So I'm going to do that, and then I'm going to do it again. So scaling up 2/5 twice, right? That shows me right here. Let me grab my pen again. So I can think about it as scaling. Again, we want to think about the visual that we're helping kids create. I've scaled it up twice. That is showing 2 scaled up versions of 3/5. And what does that look like? Right? Or 2 groups of 3/5. Yes, it does translate through, but again, we want to be thinking about how is it going to translate all the way through? What would it look like if I'm doing 25% times 80, right? Think about all those visuals that we're going to help create for kids. That's what we want to start with our base. How we talk about multiplication with single digit multiplication, we want to be able for that to transfer as they progress up into all kinds of versions of multiplication, whether they're multiplying with decimals, fractions, percentages, anything that they're going to be doing. So the final point that we want to talk about, and this came up multiple times in your guys' comments, so thank you for bringing this to everybody's attention, is that context matters. It really does not matter if a kid shows you 4 groups of 6 or they show 6 groups of 4. When all you put out there in front of them is 4 times 6. It honestly does not matter. And we should not be sticklers about how they model it, or even if we're putting that into an area model or an array. Does one of these have to be the rows? Does one have to be the columns? No, it does not. It does not matter unless it is in some kind of a context. When you put a bare problem into context, then those numbers actually mean something. One of them is the multiplier and one is the multiplicative unit. Once you put it in a context, without context, it is up for interpretation. And a kid could make 4 groups of 6 or they could make 6 groups of 4. Once you put it into a context, then take a look and see how they are seeing it. So an example of this would be, let's say Christina has 3 bags of books with 15 books in each bag. How many books does she have, right? And I'm closing my eyes because I'm creating that visual picture. I can picture myself holding the 3 bags and how each bag is probably really, really heavy because it has 15 books in each bag. That is a completely different visual than if the problem was Christina has 15 bags of books with 3 books in each bag. How many books does she have? Both of those questions have the same answer of 45. I'm still holding 45 books, but the visual picture that is represented are completely different, right? The second one, I'm totally visualizing myself with like my arm filled up with bags. Each bag only has a few books in it, but it is just full. Kind of the way I bring groceries in when I come home from the grocery store. I pile on all the bags so I don't have to make multiple trips. That's what I'm envisioning. So the context creates the visual for kids. It doesn't just happen with those bare problems. So we need to put it in a context if you want kids to have a discussion about which one is which one is the groups, which one is how many goes in each group. The technical words for those is which one is the multiplier and which one is the multiplicative unit. So Kim asked, I missed the difference between a multiplier and the multiplicative unit. So basically those are just formal terms for which number is the groups and which number is the amount in each group. And the reason we don't just call it that, I did learn it that way, that one is the groups and one is the members in each group. But as we talked about in the first part of this video, is that multiplication really is just a scaling process. It's not just groups of, and that's why we have these formal words, is that one number is the multiplier. It tells us how many times we are scaling. And then the multiplicative unit is the amount we are scaling. So in the example of 4 times 6, when it's just the bare numbers, it really doesn't matter which is which. Nothing is telling us this one is the multiplier and this one's the multiplicative unit. And that is due to the fact that it's commutative. So it really doesn't matter. You're going to get to the same answer. You can choose to do 4 groups of 6 or you could do 6 groups of 4, whichever is easier for you. And that's one of the points we made, is that like it's not this way. When it is a bare problem, either one of those can be the multiplier, and either one could, then the other one has to be the multiplicative unit. But when it's in a context, like the Christina with the bags of books, so let me come back to that one. So when it was Christina has 3 bags of books, there's 15 books in each bag. The 3 bags is the multiplier, and the multiplicative unit is the 15. It's telling me how many is in that group. It's telling me take that 15 and multiply it out 3 times, scale it up 3 times. That's what that problem is saying. But when I did it the reverse way, where I had 15 bags and there's 3 books in each bag, the 15 is the multiplier. It's the one that's telling me how many times to scale it up, because there's 3 in each bag. Okay, does that help make sense? But again, it is all dependent upon context. Context tells us which one is the multiplier and which one is the multiplicative unit. And if it's just a bare problem, kids can do it either way. And this is helpful too, to not just think about it as groups of, because kids are going to move into those multiplicative comparison type of story problems where it's something like, you know, I bought a t-shirt that was $5 and I bought a pair of jeans that were 3 times as much as the t-shirt. I wish I could get jeans for that price, right? I love it when I can get jeans for that price. But that's where multiplication is going, even with whole numbers. It's not just groups of. Kids start to get that comparison where they are, it's a set amount and then you have to scale that amount. You don't see the groups of t-shirts inside of my jeans, right? In that story problem. So again, it was the t-shirt costs $5, my jeans cost 3 times as much. You don't see that to be scaled up. It's not, you know, it's harder for kids to visualize because it isn't groups of. That's why we need to help them see it as that scaling piece, and that's what multiplicative comparison is really all about as they move up. I also have a post that is by somebody else, Valerie Falkner, that I love. She goes into great detail about why the order does not matter, even when you are using arrays and area model. And Annalisa, if you can grab that, it's towards the bottom if you want to grab that link and put it into the comments for everybody. So one of the things that I wanted to read out of that for you, though, is that the common, I guess, complaint or argument that people make is, well, we have to teach them a set way to do it because later, like in high school or junior high, the teachers are going to expect it a certain way. So they shouldn't, number one. And there is one spot, she says, they did, however, mention that there is one decent argument for this position. This comes directly from Valerie's post. That is that when we get to algebra, there is a formal understanding that the first numeral, adjective, or factor in a multiplication expression does represent the row in a matrix, and the second numeral, adjective, or factor represents the column. But this is still not reason enough to make this a rule in an elementary class. She goes on to explain that when you formalize ideas into rules too early, you detract from students' ability to have discussions and describe their thinking. You also injure their ability to think about the difference between an abstract expression, like 3 times 4, a tool to represent its meaning, like an array in rows and columns, and the actual thing you want it to represent, like the area of a patio. So multiplication really can be seen as groups of, but it really is so much more than that. Allow your students to share how they think about multiplication. Keep that progression in mind, that multiplication really is a scaling process, and the order of how kids say or model the problem really does not matter unless the problem is in a context that helps kids see which number is the multiplier and which one is the multiplicative unit. Okay, so I hope this video has helped you build your math mind so that you can build the math minds of your students.